Okay, so I would like to invite our next speaker, Daniel Landau from the IDC. He will talk about moving without body, a BCI dance expl- pla- exploratory study.
Okay, good noon to everybody. Thank you so much for the introduction and for this exciting conference. I think this lecture is going to be slightly in a different perspective. So my work is in the field of arts and media art. And typically I explore the complex relationship between humans and technology, human and body. And if a typical artist uses a canvas or sculpture, a media artist, in one hand, I think applies the same observation on the world, but as our world is changing at such a rapid and exciting speeds, our technological environment is something that is the focus of my artwork. Now, what that means in terms of my practice is that I can normally incorporate designing systems, planning them, then piloting the systems, finally entering production where I kind of take the different media components, and then the result could be a stage performance or a site-specific performance where I take the work into the world, which is also a theme that you're going to see how I applied in the BCI exploratory project that I'm going to present. So brain-computer interface is a technology that I was introduced when I came to work or was invited into Doron Friedman's lab. Very curious, very suspicious. You know, when we're talking about rich media, you can easily see the limitations BCI has. But there was two elements that I was very intrigued. One is the relatively robust signal of motor imagery. So the previous projects fit in and did a lot of justice for what I'm going to present. And the other part was that I saw the potential not to actually focus between the communication between a brain or human and a computer, but I wanted to take the systems into human-to-human interaction. So from that perspective, using the motor imagery signal, I devised a project which was based on taking the EEG signal of paralyzed subjects, and that's the point where I changed the term subject into a performer. So a paralyzed performer who has been going through several sessions to train his motor imagery with a similar system we saw before. A second aspect of the system I designed was haptic devices. So again, very much in line with what we saw before, but instead of giving the haptic feedback to the BCI performer, I distributed it to dances. So it was a paralyzed performer thinking about movement, haptic devices kind of prototyped and mounted on healthy or able dancers. This is a moment just to say that it was developed in the lab here with a great deal of help of Doron Friedman and Jonathan Giron. So we had the BCI performer training, the computer learning his performance, and the dancers receiving the signal. And the motivation there was to explore the quality that we find normally in dance, where it brings a strong sense of togetherness, a strong sense of well-being, and to imagine, try to explore, would this system kind of enable an experience which the paralyzed dancer cannot experience? Will such a system enable the two performers feel something that maybe two able dancers might be feeling? So the first part of this system was to design a one-way signal. So the motor imagery translated into a movement corresponding to the limb. So we had three classes. We had like right and left hands and legs. They were transmitted to corresponding limbs. So there was a sense for the healthy dancer, what the paralyzed performer was thinking. We decided on a very simple response since, again, when two people dance, there's such a rich amount of visual and sometimes tactile or physical stimulation. So here we decided that we'll take a very slow movements, of course, also due to the temporal resolution the EEG system has, but we just wanted to explore how would that system feel. Okay, so we're not in the quantified field of measuring and see the BCI improvement of such a system. And we compared it with a system that had only computer-generated signal. I'll soon show some short clips. And eventually, this is a second part of the experiment where we devised a bidirectional system. So the first part of the paralyzed patient sending his thoughts about movement, and then a motion capture system bringing back, again, tactile feedback to the paralyzed performer, and in that sense kind of closing a loop of this intersubjective space of dancing without moving. So let's look at two short clips. So the first part was dancers receiving tactile signal from the haptic devices we built and improvising. So it's a very short, let's see, maybe we need to click. Okay, no click, but let's see if Vimeo works. Okay, let's see, check it out. Oh, something's happening. Okay, here we are. So basically, all you're seeing here is dancers receiving signals. So the haptic signal has no quality of human touch or intention, and they improvise. The next phase was to create a system as described, that the signal is known to be coming from a paralyzed performer. And let's have a look on how that looks like. Okay, so this is a short excerpt of several pilots we ran. And after these sessions, we carried a semi-structured interview. So we explored kind of in a qualitative way, how did it feel? How meaningful was the reception of these signals, knowing that it came from the thoughts of the performer. And yeah, this is
אדם
something
חד
else.
המימד היא הפקה בריטית-ישראלית יחידה מסוגה.
Good, yeah. So what we were exploring there is, again, this subjective, this intersubjective kind of space that can occur in such a system. And to conclude, in terms of what the goal of such research is to take a technology at its early stages and speculate. What would it mean, not just from the engineering perspective, not, of course, for the very interesting and inspiring scientific elements that can come out from such a technology, but indeed to inspire and speculate what it may mean when it becomes more robust, becomes part of our lives, and hopefully maybe improve well-being for people that suffer from the lack of the ability to move. So thank you very much.